Hi guys, I'm back. So, in this question, we are going to be doing Form 4 Chapter 2, if I'm not mistaken. Okay, let's read this question. Diagram 14.1 shows a trolley placed in the front of a compressed spring. Okay, compressed spring, we already know that this spring, it has energy. It's a spring, it has elastic potential energy, more to be specific, elastic potential energy. This elastic potential energy will lead to a force. And this force will be push. It will push the trolley. Push the trolley up. Okay. Okay, diagram 14.2 shows a trolley placed in front of a spring. Okay. Shows the trolley after the spring is released. Apa ni? Shows the trolley placed in... Okay. Now, diagram 14.2 shows the trolley after the spring is released and stopped for a while at the end of the track. Okay. It moves up, okay, betul, and then it stops for a while here. Okay. Now, let me just speak in theory. Okay, this elastic potential energy, it has a force. It pushes this trolley up. So, what happens now? Okay. What happens is that when an object is being pushed, okay, let's talk about inertia. Inertia is a tendency of an object to remain at rest or if moving to continue its motion in a straight line unless an external object is acting upon it. Am I right? Wait, let me check. To continue its motion in a straight line at a uniform velocity unless an external motion is acting upon it. So let's say, okay, now we see that it's moving already. So in this case, at this point, there's zero resistance. Resistance is not being taken into account. So this object is moving freely lah kononnya. Okay, it's moving freely. Okay. So now, in this case, as time increases, the speed of the object or the velocity of the object will continue to increase. It increases at a constant rate. Okay. It increases at a constant rate as time increases because as I'm speaking right now, time is constantly increasing. I'm speaking for 3 seconds to 4 seconds, but the speed that I'm talking in will constantly increase. So it's like that. But what we must know is that when there's force that's pushing this object to increase at increasing velocity, so velocity is not equal to 0, and this means that there will be an acceleration because F is equal to ma. There's mass, there's force, there's obviously acceleration. Okay, now that we've got that settled, what we know is that it's moving at a uniform acceleration. Because why? The acceleration of this object is the same. Acceleration is what? It's the rate of change of velocity. Okay. Rate of change of velocity. In this case, the velocity is increasing at a constant rate. So if the velocity is increasing at a constant rate, it means that what? There's no rate of change of velocity, ladies and gentlemen. When there's no rate of change of velocity, it means that what? Acceleration is constant. Okay. And if you look back at your Form 4 Chapter 2 textbook, page 37, you'll see that when uniform acceleration, the graph will look like what? The graph will look like this. Directly proportional. Velocity is directly proportional to time. But wait, that's not all. It says that it will stop for a while at the end of the track. So it stops for a while here. What does that mean? It means that there's some sort of resistance, friction that's stopping the movement of the trolley, but only for a while. But after that, it won't continue to increase, okay? Because when you increase, you need another force, something like wave lah, like something like resonance, like you need a push to stop it from reducing in its amplitude because of the loss of energy. But in this case, there's no force exerted on it. It just says it stops for a while at the end of the truck. So after that, its movement will decrease lah. Decrease where? At a constant rate, it continues to decrease. So it means that constant uniform deceleration lah. So the graph will literally look like the ramp. The answer is B.